All right, so lab number 2. I think the lab is pretty cool. Before we get into lab, a couple things. So let me bring this up. I think I mentioned this with lab 1, but there's a whole lot of notes and emboldened instructions at the top of these labs. Please take note of these every time when you go to start a lab. These aren't necessarily the same thing every time. Some of them will be repeated from lab to lab. But like in particular with this one, you're entering a lot of data. And this has specific instructions about the format that data should be in. If there's syntax that you need to use, if you're taking a measurement of a sunrise time and you want to say it's 6 o'clock a.m., it's not 06:00, it's 6.0. They want a decimal hour, things like that. Where are you supposed to put the AM, PM? Take note of it, because if you put something in the wrong syntax in WebAssign and you go through that and you do your whole lab that way and you hit save, it'll just reload a completely blank lab and give you some little red message somewhere that says, sorry, that was the wrong syntax. So lesson 1, read the directions. Lesson 2, save your assignment often. But if you read those, it should kind of avoid some of those issues. You're going to be asked to take measurements at all 4 seasons, so summer solstice, winter solstice, and the vernal and autumnal equinoxes. Summer and winter are pretty easy to figure out. What's the key thing to note about the Earth's orientation in summer? What's towards? It's pointing towards? Yeah, the axis is tilted toward the sun. Winter, it's away. In the fall and spring, that's not going to be as obvious, right? It's going to be to one side or the other with reference to the sun. So I think this diagram is a good reference point. I think it's in the background section B. You can see if you're looking from Earth to sun in fall, it's tilted to the right, or vice versa in the spring. So just refer back to that if you get confused. The other way to do it, or the other way I do it, is to actually take the globe and march it around a fake sun and try to figure out from that. You know the way the Earth orbits the sun. You can kind of pretend you're the sun or pretend where it is and figure it out. I'm glad to help you with that at any point if you need help. Okay, so what are we actually doing? So we're going to figure out, or we're going to measure how length of day varies with season and with latitude, and how the sun's angle above horizon at midday at noon varies with latitude and with season. So like I said, there's a lot of measurements to take. This is a 2-week lab, so you have more than enough time to take all those measurements. In this first part, so I skipped B1, there's just, you're focusing on Chapel Hill in particular. But the majority of procedure part B, you're going to pick 5 cities. And notice the instructions. You don't want to pick one that's too far north. So below the Arctic Circle, it says below 66.6 degrees. I wouldn't really even go above like 65, 63. At that point, some things get strange. And then, again, above the Antarctic Circle, so above -66 or above 66 south, somewhere up here. And then for each of those cities, you're going to record the latitude, and then you're going to go ahead and set your system to the various seasons and measure either a sunrise or sunset time. And what that is depends on where the sun and Earth are with reference to each other. Sun, Earth versus Earth, Sun. Determine sunrise or sunset. You'll figure that all out. I'm going to give a quick rough shot preview of the entire lab, and then I'm going to go into the specifics of the actual setup. In the second kind of half of the lab, you're going to be measuring how high the sun is at midday. So you're going to have a protractor. Can I grab that one from you? You're going to have a protractor with a piece of string on it, and you're going to put the protractor on the city in question, pull the string out horizontally, and take a measurement of that angle. So I think the instructions say point it towards the middle of your ring light. Again, this is a different setup. You don't have a ring light. It's not necessarily going to be the middle of your light source. Just you're going to be in groups of 2 or more, so have one of you guys hold the string, the other one make sure it's nice and flat, parallel to the ground, to the lab surface. And then the last part is kind of a little thought experiment on making a measurement of Earth's diameter. So I'm not going to go into too much detail on the actual components. Again, there's a lot of measurements to be taken, but you won't have any issues getting it done, I promise you that. But let's get over to our actual setup. So I'm going to work with this one just so hopefully most of you guys can see this. You have your little box, right? This is the frame for your structure, and then you see these pieces of black felt or fleece, possibly. And so what you're going to do is going to use these to form a little like shroud around 3 sides. So both ends and in the back, this would be their lab setup. They'd take these binder clips and clip it, to this corner. It's stuck at the moment, but you guys will get it figured out. To that other front corner, and you'd have 3 sides of black felt. Actually, you guys mind pulling that computer off, and we can actually show everybody what it looks like. And would you help me out? Pull up that one side. So this is actually this is a short piece, so we don't need that. No. Anyway. So pull it around like this, so it's just covering the 3 sides. And then we have another piece that'll go over top. All right, so just cover the back and the 2 sides with the one piece. Then this other piece would go completely over the top of it. The other thing you can do is once you get your light set up, some people like to just put it over 1/2, kind of like this. I mean, this is a smaller piece, but we have more of it. So this kind of funnels all the light in the direction of your globe and not to everybody else. We'll take these down so you guys can see what we're doing. Okay. We have 2 lights and a metal stand. You're going to notice on these stands there's a piece of tape with a marking. So this is where you should clamp the lights on, and they will hang down from there. So for example, I would have my light. I would clamp it right there, and it would just kind of sit like that. The other one would sit on top of it. This would be our simulated light source. You want these to be pointing in the same direction and along the same kind of vertical line. And then your globe would be on the opposite end of your little setup, and preferably right in line with your light source. One other thing to note about the globe. So what you're going to be doing is moving your globe around. So let's say you pick a city. Let's say that for me that city's right here. I'm going to have it on my setup, right? I'm going to have the light source, which is going to create a division between night and day. It's going to create a terminator line. And one of you is going to kind of put your finger on that city and move it around, and then your partner's going to say, okay, right there's in the terminator. And then you're going to follow a line of constant longitude up, and then read off an hour from an hour circle on top, and that will be either a sunrise or sunset time. That's the first half of the lab. The process for doing that is to get your city on the terminator. First you're going to set the season. So in this case, if I wanted to do summer, it'd be something like this. Right, the Earth is tilted towards my light source. I'd then move the city to the terminator, and I'd adjust my hour circle so that noon was forward. Right, directly toward the sun should be noon, wherever that location is. And then I'm going to read off the time on the top. Be careful with this part. Make sure that your globe is pointed in the right direction in terms of the season, and that your hour circle has noon exactly forward. These don't have, they only have every hour delimited on the top here, and it's not a very big scale. So if it's off by just a little bit, that's going to change your time by half an hour to an hour. So just try and be careful with that. It's going to happen regardless, right? It's not perfect world, but it's pretty good. So that's the basic idea. You guys can adjust it as you want. We have extra clips. We have extra pieces of felt or fleece. Personalize it as you see fit. So once you take all these measurements, whether you have time in the lab or you end up doing it at home over the next couple weeks during your analysis, we're going to ask you to graph all this data. And so there'll be a link in the website, and it's going to ask you to make a graph of, like say for this first part, length of day versus latitude. So if you open this link, it'll go to a web page that has a plotting tool that we created. And this is what it's going to look like when you first open the page. So what we're going to want to do is plot length of day versus latitude. So how does the length of day vary as latitude changes for our 4 different seasons? So the first thing you want to do, first thing is to clear out all the data that's in here. It's going to have a lot more rows than you need. And if you just start manually entering, there's no good way to clear out the rest of it. You can't it's not like an Excel spreadsheet. You can't select a bunch of rows and delete them. So just clear out to start. They're going to change the number of lines to 4 lines. And if you notice, if I hit plot, 4 lines show up. One thing that's going to be important with these is you always want to properly put in the plot title, both the y and x axis labels, and then the data labels, which are cut off currently, for each of these lines. So let's say that I wanted this to be summer, winter, fall, spring, and that was corresponding to these columns as they go across: summer, winter, fall, spring. You can see the last little box there is the data label. And so I would just label them with a comma separated in the order that I entered them in the spreadsheet. So summer, winter, fall, spring. And those data labels will show up exactly how it's supposed to. So that's pretty straightforward. And then, again, X and Y axis labels with appropriate units. So if I'm plotting the length of day versus latitude, what are my units? What's the units on length of day? Time. So it's going to be like hours. And on latitude? Degrees. So you want to include both of those. It'd be like length of day, parentheses, hours. Latitude, parentheses, degrees. Include those. You will get points off if that's not all included. It's kind of a frustrating way to lose points on a graph. Whenever you're asked to plot something, so in this case, length of day versus latitude, length of day is going to be on the y-axis. You're asking how does length of day depend on latitude? So just think of it as y versus x. Length of day on the y, latitude on the x-axis. Is that clear? Is everybody good on the plotting tool? You're going to be using this a lot this semester. It's kind of why we made it, to make it easy for these labs, just one place to go. It's a lot better than plotting stuff in Excel for some things. Not being able to manipulate the cells gets a little annoying. But. Questions? Okay, we have a couple more things to say. So first of all, you'll notice that we have 5 setups on each of these benches and then 1 or 2 in the back. None of those should be empty. Work in groups of 2 or 3. Before we get going in the lab, we have one last thing to do. So everybody open your computers, please. In lab number 3, you are going to be asked to monitor a planetary system, a Jovian planet, for a 2-week period. Since this is a 2-week lab, we're going to put those jobs into Skynet right now. And that way they'll be taking those images for the next 2 weeks while you guys are working on this lab. So open up your computers, get on the internet, and navigate to Skynet webpage, and then log in. And go to the observation manager and add new observation. And so we want to choose one of the Jovian planets. That would be Jupiter, Saturn, Uranus, or Neptune. Saturn is not currently observable, so Jupiter, Uranus, or Neptune are left. It doesn't matter which one you choose. Just decide on one. I'll do Neptune. Look it up. It's clearly visible. I would rename it something. Lab 3, whatever. Lab 3 Neptune. Okay, and then if I have a copy of Lab 3 brought up right here. So if you look up here, depending on what your choice is, this is the filter and exposure time you're going to use. If it's Uranus or Neptune, you're going to use the open filter for 1 second. If you chose Jupiter, use the V filter for 0.03 of a second, 0.03 seconds. So once you've looked up the planet, changed the observation name to whatever you want it to be, then go ahead and select the appropriate filter. I'm doing Neptune, so I'm going to choose the open filter. So there's a little box, but it says if interrupted. You want to change this to continue on next available telescope. I almost forgot this part. That means that if you start this 2-week observation on prompt 3, if that's the first telescope that it uses for the first night, it won't just only use prompt 3 the rest of the time. It'll take whichever one is available that night. Okay, so you looked it up. You changed this to continue on next free telescope. You chose the appropriate filter. And then hit next. And choose the telescopes you want, prompt telescopes. Okay, and now you want to take 2 exposures. So that's 2 per night, just in case one of them doesn't come through. The duration is whatever is in this chart. For Neptune, that's 1 second, which is what I'm doing here. Oops. And you want to repeat these 14 times at a minimum, right? So you want at least 2 weeks. What we're going to be doing is we're going to be taking these images and we're going to be watching one of the moons around these planets. And we're going to take measurements. We're also going to make a nice little movie of it orbiting around, but the point is to take measurements, so 2 weeks at a minimum. And you want to change, so it's 14 exposures or whatever, with 1 day between groups of exposures. So it should look something like this when you're done. You really only need like 5 nights worth of images, but we do it for 2 weeks because you're going to be back in here starting lab 3 in 2 weeks. So, okay, then you hit next and confirm that everything is hunky-dory. And so now should be in your observation manager, should be active. My one from yesterday got 2 images back already, so that's good. So now you're going to be getting images every night. You don't have to touch it for the next 2 weeks. It'll just, every night it'll take an image. You may not get one back every single night. If it's cloudy, you won't get one back, etc. But you should get them back most nights. Everybody good with that? Okay, so go ahead, get your setups going, clip up your film. Make sure the light bulbs are screwed in before you plug them in and turn them on. I don't want you guys getting shocked or anything. It's going to get warm in here. These are like home security lights. They're pretty bright. I'm just going to warn you right now. But they work well for our purposes, so just a word of warning. In a couple minutes, once you guys get the lights on, I'll turn the overhead lights off and it'll make it even better. Oh yeah, and so there's 4 sections, procedures A, B, C, and D. You should do half each week. If you want to do C and D, you don't need the lights on this week. That's just the angle measuring part. You don't actually need a light source. It's up to you guys how you want to do it. Decide amongst your own individual groups.